All right, well, good evening. We're going to get started tonight. We're going to talk a little bit about network fundamentals. We're going to describe how networks impact our daily lives, describe the role of data networking in human network, identify components of any data network, we'll identify the opportunities and challenges posed by the converged networks and what converged networks mean, describe characteristics of the different types of scalability, quality of service, security, and fault tolerance, and then we're not really going to install and use IRC clients in a wiki server, but we'll talk about it. All right. How do networks impact our daily life? Give me some examples.
Sharing files between computers.
Peer-to-peer sharing. Okay.
Businesses.
Businesses.
Email services.
Email services. What about EDI? Electronic data interchange. What about bill payments?
Absolutely. Online banking, big deal.
Exactly. So when we think about these different ideas and how prevalent they are in our society, we're talking about instant messaging. Well, that was pretty popular back in the early 2000s. Basically, it's one to another, peer-to-peer type conversation. Then we have blogs, which they still do a lot of blogging now, or weblog, we should say. Podcasting used to be a big trend, but it's not as much anymore. It can explain why, or ways that we use information networks to share and collaborate improves the teaching and learning. Because I can sit here, like I am now, recording this lecture, and I put it on YouTube, and then you'll be able to view it at any time you need to. So that gives you a better learning environment. Describe ways communication over network changes the way we work. Well, how does it affect the way we work? ATMs, phones, we're on VoIP phones now, cell networks. You don't have any pocket PCs anymore, but they all can come back to a single source. Describe the way the communications over network supports the way we play. RPOGs. Right, David?
Oh, yeah.
Is it ROPG or RPGOG?
MMORPGs. I'm teaching my 10-year-old niece how to play World of Warcraft.
Oh, that's terrible.
I know.
Deal breaker this time.
But it works. Basically, a basic characteristic of communication. First, you have the two players involved, the two participants. Rules are agreed upon in the first statement that is sent out. So if Lance spoke nothing but German and I speak English, what is our communication language going to be? It could be either or, right? If I spoke German and he didn't speak English, or he spoke English and I didn't speak German, we could sit here and say, we're agreeing that we're going to talk in English and he will be able to talk to me. Because rule number 2, important information may need to be exchanged. And then various modes of communication may impact the effectiveness of getting the message across. So that's where you get your auditory, that's where you get your visual, the different type or hands-on, tactile learning. That's how it comes across. So how does data network play a participant, or is a participant in communications? How does it work? Brandon, what do you think?
How does data networks play a role in communicating?
Mm-hmm.
It's the way that you exchange data between two people.
Pretty simple, isn't it? Data networks are the backbone to exchange all information, pretty much all information out there, other than word of mouth, obviously. If it's in electronic form, it gets exchanged over that network. So what types of devices do we have that make up these networks? We have devices, a medium, message, and rules. Like we just talked about, the rules are how the messages are going to be translated or what they're going to do. That's what governs the transmission. The messages are the single bits of information that are flying across the network faster than we could ever think to comprehend. Medium, that's the network cabling infrastructure that it goes through. Okay, so when I talk to you, what type of medium is this? You need to tell me it's a WAN line, serial, fiber, copper, whatever. That's the physical medium. And then the devices are going to be in devices, could be phone, satellite, PC, cell phone, whatever. What is a converged network, Armand?
Conversion.
What is it? Without giving me that definition, what do you think?
Like satellites.
No? They could partly play a part. David, what do you think?
It's a net, without quoting that, it's just a network that can convey messages over multiple forms.
Well, it's actually a network that can allow multiple forms simultaneous. That's what we call converged network. Because your VoIP phone systems, they run data from the computers and they also run the voice data. So that's a converged network. That's what we're talking about when we talk about convergence. And then when you're streaming videos over the same thing. So essentially, what is the internet? Is it converged? Yeah. Think of a Skype call. Video, voice, data, all going through your computer. So what are the 4 characteristics that are addressed by network architecture design? Fault tolerance, right? How are we going to make sure our system does not fail? And within that scope, we have a term called redundancy. What is redundancy to you, Lance?
Well, you have like backup plans in case something fails, then things don't go to.
It's not necessarily a backup plan per se. It's a alternate route, or it's an alternate physical medium that actually allows you, in case one breaks, you still have that connectivity. That's fault tolerance. Scalability means the growth of the network. The good rule of thumb is take how many network drops you're going to do, divide it in half, and then add it to the total. So if you had 12 drops, you would add 6 more. That gives you good scalability. So you can have 6 more devices put in that room because you never know how many more drops you're going to need to run. Quality of service. What kind of quality of service do you think it would be, Armand?
Like how, what, I mean, the budget or how you going to use? Are you going to use a cheap modem or are you going to use the best modem and kind of security and stuff you put on the device you try?
Kind of. The quality of service is how many times, what is the percentage of failure? You want the least amount of failure. So you want that 5.9 reliability. Y'all know what I'm talking about, right? 5.9 reliability, not 99.999%. So if I say this network is 5.9 reliability, it means it can go down for 3 minutes and 26 seconds a year.
It's like a Six Sigma thing.
No, it's 4 nines. You can go take it down for 3 days out of the year.
Small number of defects.
Or I'm sorry, not 3 days. You can take it down 3 hours is what it was. Basically, it's the rule of 3. It keeps getting bigger. 6.9 reliability, you just can't go down. I mean, you have like millisecond of downtime. It's impossible to have 6.9 reliability. Security. We talk about firewalls, ACLs, and encryption. ACLs, access control list. How many of y'all remember that from network security? An access control list can be mandatory, discretionary, rule, or role-based, right? Well, in routing, you can actually have access control lists that are physical, but you can have them depending upon a role, like if it, or a service, like TCP or IP traffic or whatever protocol you want. Or you can have it specific to users, groups. So there's a lot of different things you can do. Packet switching helps us improve the resiliency and fault tolerance of the internet information, or the structure of the internet. So what what is going to be, what do you think when you think of packet switching? Do y'all know?
Transferring data.
It's what allows the switches to transfer data from one place to another. So it gives you that redundancy availability to where you can have multiple paths. So if I'm trying to call David, I can go to Lance to David, I can go to Brandon to David, or I can go to Armand to David, or I can go straight to David. And each packet that goes out may go a different way. That's packet switching, because it switches the direction of which your traffic can go. Until we start getting into routing and we can define straight paths and direct paths to the next hop and where it needs to go. Characteristics of the internet will help scale it to meet the user demand. Why? Because it's hierarchical. It's like a military chain of command. You keep getting bigger and bigger and bigger. They all have common standards. IEEE 802.3 standards. You have protocol standards, which are your TCP, IPs, UDPs, SMTPs, all the Ps really. Factors that affect the quality of service, your bandwidth, how much can you actually put down there, the priority of the traffic. If I give everything with high priority, what's going to happen?
You're gonna get choked up.
You're going to get choked up. So you keep everything with a small amount. If it's your VoIP line would always have priority over data. Why? Because you need to keep that quality of service for phone. Financial information, and then your lowest priority would be those web page people. Quality service mechanisms, they just make sure that everything fits together in order that certain traffic doesn't overdo another traffic. Okay? They all work together. And remember, with converged networks, all traffic is not the same. Why would you want your networks to be secure? Yeah, you want spy versus spy looking at your credit card statement there, don't you? So what are the basic ways to secure data? I like to say that this slide is wrong. You use these like you'll ensure confidentiality by authentication and encryption. You maintain integrity by digital signatures, and you can do availability by having the devices such as firewalls or redundant networks and no single point of failures as far as keeping your system up. But I like to go a step further and call defense in depth into play here. How are you going to secure your network? Well, you need to start with the center and work your way out in layer approach. You don't want to make sure that you have just one piece of security between you and the end user. Because they break it, guess what? They've got access. You want to put as many layers of an onion as you would out from your data. Because your data is sacred to you, right? Any questions on chapter 1?
Ask the guys at Target how sacred their data is.
So, I mean, no questions on this? All right. We're going to start talking about chapter 2 and the network structure. There are three different types or three different elements of the network structure. You have the source, a destination, and the channel. Okay? Your source, that is what starts the conversation. The channel is the communication that you're doing, and then the destination is the receiver. Okay? The channel is also known what type of medium that we're running. So, T1 line, things of that nature. We're going to define a network as data or information networks capable of carrying many types of communications. Sounds like convergence, doesn't it? Remember, we have two different ways that we can send data. We can do segment or we can do it multiplexing. If I'm going to send it in small chunks, what do you think I'm using? Segmentation. Because I'm taking the whole thing and I'm breaking it into little small chunks, right? Those small chunks will go over the LAN, go out to the inner network, route its way back to this other LAN. And the different components of that, you have hardware and you have software. Let me go back over here to multiplexing. What does it mean? It means I can send multiple traffic over at the same time, and they can be overlapping. What are some end devices? What do you think? Name me off some end devices.
Desktop,
Desktop,
cell phone,
cell phone.
tablet,
Mhm.
printer, scanner.
Exactly. Anything that you can physically touch is going to be pretty much an end device, with the exception of routers and switches. Clients, servers. When you see this intermediary device, which are your routers and your switches, they provide the connectivity that ensures the data flow across the network. So from end device to end device, it has to go through an intermediary. You know, there's 5 hops from this computer out of Rose's network, right?
I didn't know that it was 5 hop.
From here to this room switch, the switch to the router,
Okay.
the router over to IT, there are 2 routers over there, and then out the gateway. So it has 5 hops to get out of here. And it does it fairly quickly, too. It's out of the network before I get out the door. Network media. Like I said, the media is what we also call the medium. It's going to be copper, fiber, wireless, coaxial, whatever connects the networks together. So if I said define a LAN, give me an example of a LAN.
This classroom.
This classroom. What about a WAN?
This wireless.
No, that's,
Oh, that's
The
REGAN.
internet.
Sorry.
The internet.
no, not really.
The school doesn't have
Midale City. I know.
It could be by definition, but it's called something else.
In Midale, they have they call VPN, which is they connect to each other. That's kind of thing.
That would be. It's actually called the same thing he's trying to call it, but it's
So, would like AT&T's network, would that be considered a WAN?
that would be a WAN,
Okay.
Cox, because they have a bunch of LANs. They've all connected together. Now, when they leave there, then we start getting into the internet, and I'll explain that here in just a second. Here's the internet. The internet is defined as a global mesh of WANs. So just think of network. You have your LANs, your WANs, and then the internet. And here's some of the different types of things you're going to see in Packet Tracer. We'll have our routers, switches, hubs. Notice the difference between a hub and a switch. You have server, desktop, laptop, IPv phone or IP phone. We're not going to use. You'll have a wireless router, wireless access point, or medium, whether it's WAN or LAN. And if it's going from router to router, you'll see this type of symbol. If it's LAN to anything behind the router, it will be a LAN or wireless. And then you have your firewall, which looks like a firewall. Now we're going to talk a little bit about network protocols. What are network protocols? Well, network protocols are used to allow devices to communicate successfully. Basically, they define the way that this protocol will talk, or this group of data will talk. It gives it a format or structure. It tells it the process by which it will share the information with others on the network. It defines how to do the checksum values of the error checking capabilities for the system and on system messages between end devices, and then talking about how to set up and end terminations or terminate the conversation. So, describe protocol suites and industry standards. Well, what is a protocol suite? Name me a protocol suite.
ISO.
Nope. That's a standards organization. Well, it's actually not the standards organization. It's standard name. No, ISO is the organization. That's right.
TCP/IP.
Yes, TCP/IP. It's a protocol suite. All a protocol suite does is define the common language, how traffic will be sent, and sends a signal when it's finished. That's all it tells it to do. Pretty basic. A standard is a processor protocol that has been endorsed by the network industry and ratified by the standards organizations, like all your 802 standards. Let's talk about the different protocols. You have HTTP, TCP, IP, and Ethernet. HTTP is going to be a layer 5 a layer 7 application layer protocol. TCP, layer 4 protocol. It is connection bound, right? In other words, I have to have a true connection to someone in order to do it. IP is a layer 3 protocol. When we start talking about IP addresses, we're talking about what is on routers. Then we have the Ethernet layer, which is your physical layer down on layer 1, right? And actually in between there, we have what was called layer 2, where we talked about the MAC, media access control, and that's where your MAC addresses also come from, in the data link layer. Technology independent protocols. There are many different types of devices, and they communicate using the same set of protocol. Was that fine? Do you think it's right? What do y'all think?
Could you repeat the?
Do you think wireless access is the same as an Ethernet?
They have different authentication process.
Okay. So you don't think web traffic going over wireless network is not the same as going over the Ethernet network?
It is.
It's identical. However, the way that it communicates between the end device and the network are different. Now let's discuss the difference between the TCP/IP model and the OSI model. What do? Well, they assist in protocol design. They foster competition. Changes in the one layer do not affect any other layer. It provides the common layer of network or common language. The TCP/IP model has 4 layers. It has the network access, which is your data link layer and also your physical layer. You have the internet layer, which is your network layer. Transport, which is your transport layer. And then application, which is your session, presentation, and application of the OSI model. Okay, your application represents data prior to being encoded and encapsulated to send down the protocol stack. Transport layer then takes that data, encapsulates it, and then supports the communication between the devices by saying, okay, here's how we're going to talk. Internet then determines and gives the IP address from your local machine and where the IP address is on your destination, and encapsulates all the transport layer data. Then the network access encapsulates all that, breaks it into segments, and sends it out the media that it needs to go. Pretty easy. And basically, it goes to application, transport, internet, network, across the network, back up to network, internet, transport, and application. That's the way it goes. And here's what I was talking about by the encapsulation. You have an email. It puts down into data. The datas are then broken into segments. And then the packet then gets formed with that data and puts the network header on it with the IP address. The frame, which is puts a frame header and a network header, goes to the MAC address. And then that's converted into bits, and bits are what's sent out. But you wonder, when you look at a protocol analyzer, what do you see? Do you see bits or do you see hex? Isn't that strange? Describe the process of sending and receiving a message. Well, we've already done that. Do I need to do it again? You go down the protocol stack and then back up. Simple as that. And here's what I was talking about by the encapsulation. You have your data. You have the TCP in front of it for the transmission transport layer. You have the IP address, which forms the IP pack. Then you put it in the Ethernet frame, which is your source and MAC destination MAC addresses. And it also puts the checksum on the end of it and then sends it across. Pretty simple, right? So if I give you a diagram and tell you to tell me what's on each one of them, you think you could do it? When we define the OSI model, you have the please do not throw sausage pizza away, right? Physical data link, network transport, session, presentation, and application. And here's, like I said, it was just matching up. Physical, basically, their timing and synchronization. Data link gives you the source and physical address, which is what? David, what's a physical address?
IP address.
No.
Mac.
MAC. IP is logical. The network gives you the IP address, and then transport gives you the port numbers of what protocol you're using, whether it's SMTP, Telnet, whatever. That's where that gets into there. And then everything up is your data beyond that. So here's what you've got. You got your destination, you got your source, and you got your data. And that's what we call a protocol data unit. All right. Any questions? All right, we're going to talk about Chapter 3 now. And we're going to talk about the highest layers, which are the application layers, the functionality of the application layer. And then we'll talk about the transport layer, and then that'll be the end of this lecture. The application layer, what we're going to talk about it is the source and destination of data for communications across networks. We'll talk about what protocols are in services that are up there, and then the protocols in support of communications between the server and client. We're focusing on the layer 7 of the OSI model, the application layer, and it provides the means for generating and receiving data that can be transported to and from on the network. What does that really mean? Well, it's everything that you touch on the computer, your applications, your words, your documents, things of that nature, your emails. All that data gets encapsulated into these protocols. That's the application part, not the physical application of Microsoft Word, Microsoft Office, that type of stuff. Think of application layer as just the protocols only. Have I lost anyone? So keep them the different eggs in the basket here. They named it application, which is because that's where all the applications get encompassed into protocols. When you open an application and the application is started, the program is loaded into memory. What's loaded into memory is the executing part called a process. So when you go to the task manager and you see the process ID, that is the identifier for that application. Some applications build in protocols within the application to support network communications between them. And services are those interfaces that to access the application that may reside on a server. All right. So when we're talking about the application, we're talking about HTTP, SMTP, POP, DHCP, domain services, all those types of services. Network administrative services are all in your application layer. Does that make sense? Your FTP, all that is up there. All right. Protocols that play a major role in networking: DNS, Telnet, email, DHCP, web, and FTP, right? So what happens here? The client requests data from the server. Server acknowledges it and sends back the data. Pretty simple, right? At a 30,000 foot view.
Yeah.
when we start getting into here in a few minutes how the synchronous transport works, then we'll understand a little bit better. Some of the ones that you may have is you may have 3 telnet clients that will go into this telnet daemon, which then goes into the application server to validate and sends it back and allows them access. DNS, all it does is it drives a colloquial name to an IP address. Could you imagine having to memorize every IP address out there? Instead of going to Timbuktu.com?
If you had to type in 56.190.11.56 for every website that you wanted to go to, that'd be crazy.
Exactly. Especially with DHCP websites. Or dynamic static IP addresses. Does that make sense? Like Cox, when you get your 2 live, it's really a DHCP address, but the lease is almost permanent. But it can change when you unplug it and plug it back in. So that's what I call a dynamic static IP address, even though it's really by definition DHCP or dynamic address. The 2 protocols that you use for HTTP, you're going to have port 80 and port 443. 443 is your HTTPS, as y'all probably remember. You have POP and SMTP. What is POP? Nope. POP is Post Office Protocol. What does POP do for you? Delivers email. Think of POP as the post office. The postman comes and delivers your mail, right?
He doesn't steal it in his garage.
And then, yeah. And the SMTP transfers it out. Simple Mail Transfer Protocol. So that's the easy way to remember which way goes what. All right? And then what we have is MDA, MUAs, in Mail Transfer Agent. We have an MDA, which is the email server. Then you're going to have an MUA, which is Mail User Agent, who sends an email through SMTP to his SMTP server of wherever the ISPs or the SMTP server that he's connected to. That then takes this mail transfer agent, transfers it to the next mail transfer agent, who puts it on, let's say, this mail delivery agent, or sends it to this MDA, the user's server account for Hotmail, until the server asks for POP delivery. The mail's on hold until you ask for it. Okay? And that's how it works. All it does, this MTAs forward the email to the delivered email. You have Telnet has 2 ports. What are they?
23 and I don't know the other.
22.
SSH?
Secure shell.
Yeah.
Telnet is a shell. That's all it is. Allows you to send command line interface stuff to different devices remotely. So when you go in and you're hitting config T or config terminal, it's actually you're saying configuration terminal on the Cisco command lines. This is what you're doing. And if you block Telnet, you can't do it remotely. And if you block Con, you really can't get into it. SSH is just the secure version of it and encrypts the data or encrypts the text going across instead of it being in clear text. SMB, all it does is send a request to the client-server relationship. All the shared resources are on the server. The client sends a request. Well, these are backwards. Sends a request. The server sends back a response with the data. That's all it is. In peer-to-peer networks, computer that responds to the file sharing request is considered a server, and the one issuing it is a client. Any questions? All right, let's talk about some network fundamentals. We're going to talk about the transport layer. Woohoo! Transport layer prepares data for the transport over the network for use by applications. Some of the major functions of the transport layer is that it provides services to the next higher layer, which is the what layer? On the TCP/IP, it's the application layer. What is the difference on the transport layer? There's two main protocols, UDP and TCP. What is UDP, Brandon?
Connectionless?
It is connectionless. What is it used for?
Oh man. No.
It's used for those that you do not need an error checking for,
Oh yeah.
such as video streaming. Cox all your streams on TVs are coming out on UDP because it is not going to be dependent on a straight connection. Okay, TCP has that straight connection. Now, that's why you have your telephony, your POP email, your HTTP. Those are all going to be on transport, and you need to have fast, low overhead, doesn't require acknowledgement, doesn't resend. I'm sorry, your IP telephony and streaming video are UDP. Your TCPs are going to be reliable because of the error checking. If it doesn't get it, then they resend it. Okay, it's a little slower, and it delivers data in the order it's sent. Here's the difference between a UDP and a TCP header. They both have a source and destination. They have a checksum. But look at all this extra information. And then they all have the data segments. 20 bytes versus 8 bytes. Which is going to get there faster? UDP, because there's less overhead, right? Port addressing. Data for different applications is directed to the correct application because each application has a unique port number, right? So, if I'm sending you traffic that's port 25, what am I sending you?
Simple mail transfer.
SMTP. What about port 443? HTTPS. And then 531 is all your internet chats, IRCs, that kind of stuff. Transport layer functions, like I said, all it does is provide for the source and destination ports, sequencing to validate the order in which they are, flow control and management, your CDMAs, CAs, and CDs, or CSMAs, CD, and CA, collision detection, collision avoidance. It's all on TCP. UDP just gives you your source and destination ports. That's it. So here's TCP. Gives the sequence number, an acknowledgement number. I send you a sequence number saying, here's 1 to 1500 or 1499. It's actually 1530. And then you send me an acknowledgement saying that you got that last packet. Then I'll send the next set. Then it comes back. Then I send the next set. And you'll see that here in a minute. TCP checksum, there's your validation. And for TCP mechanisms, we have a 3-way authentication handshake. We send sequence numbers and acknowledgements, and then we terminate our session. So what I'm going to do is I'm going to send 1,500 bytes. So it says it receives 1,501 to 3,000. It should be 1 to 1500. And then 1501 to 3000 should be right here. It receives acknowledgement number 3001. I send 3001, it doesn't get there. I send 4001, it gets 4501. It sends back acknowledgement number of 3001 with 1500. What happens? It says, I didn't get this. So that these will be resent. You say, don't send it at 1500, send it at 2000. And it says, you can send it back to me at 1500. Because I sent 3,000 of them to them. That make sense? And the sequence numbers, they can come from a variety of different ways and get there at different times. Because if I did segment 1, 2, 3, 4, 5, 6, divided in segment, I send it out, it may come in 1, 2, 6, 5, 4, 3, and it's going to get organized into the correct and put in there. That's how the TCP session works. All right. Starting with byte, I'm sending 10 bytes. My acknowledgement is 1. I receive 10 bytes. I expect 11 next, and it sends sequence 1 back. All right. To terminate the connection, you're going to send the finish. That A is now finished. It sends it to B. B sends the acknowledgement that it received it, and then it sends its finish saying, I'm done. Adios. And it sends it 1 back to C, and y'all. All right. You understand it? UDP, low overhead. Doesn't establish a connection, it just floods you with the data. Doesn't mean that data is going to come in any particular order, any particular fashion, or anything. So you could send it 1, 2, 3, 4, 5, 6, and you could get 1, 2, 6, 5, 4, and not even get 3. And 3 will never get resent. So which is better? TCP. You'd want TCP connection for your bank, wouldn't you?
UTP can somewhere like
You want UDP when they're trying to take money from you. You want TCP when you're putting money in, right? Do what?
Is UDP safe than TCP?
Is UDP safer than TCP? It's all on how you secure it. All it is just the way the data flows. UDP has client 1 sends it to the server 2. The client DNS request will be received on port 43. Radius request will be coming on port 1812. UDP server just sits there and listens in case it needs to respond to anything.
Do you know what's the maximum port we could have?
65,535. You can trace the steps as the UDP protocol and port numbers are utilized. Okay. Client 1 is waiting a response on port 49152. Client 2 is waiting for a radius response on 51152. All right. What happens is the client requested something from the server for DNS port 43. It got to there. The DNS server says, okay, you came in on port 43. I'm going to send you your authentication on 49152. Sends it back. Same thing with radius server. Comes in on 1812, comes back on 51152. All right. Is there any questions?